right, so now dealing with side triangle congruence theorem. Fairly straightforward. All three sides of one triangle needs to be congruent to the other. So let's take a look at a couple examples here. So number one, all right, we have 1 to 1, 2 to 2, and then our shared side gives us our third one. So this would be yes by side. And then listing all those things out. So we have J, K is congruent to JL, K, G is congruent to LG, and then last one, GJ is congruent to GJ. All right, number two. We have 12 and 12, so that works. So it gives us H is congruent to DH, and then 20, 20, so then we have FG is congruent to DE. And then 24 to 24. So then we have GH is congruent to EH. So this one would be yes by side again. All right, so Carol bought 2 chairs with triangle backs. For each value of x, use the triangle congruence theorem. Show triangles are congruent. Which triangle congruence theorem would you use? So we have 25 to 25, 25 to 25. So then if these were to be congruent, those need to be equal. So let's go 9x minus 21 equals 15. And so we get x equals 4 on that. And this would be side for this. All right, so your turn. Work through identifying whether they're congruent, which parts are congruent. So list the corresponding parts and then state the postulate or theorem. Then explain how you know that triangle ABC is congruent to DEF, and then write a congruent statement for each pair of corresponding parts. 7, use the given information and the diagram to list all the congruent corresponding parts. Then if the triangles are congruent, and by which postulate or theorem. All right, so looking at this, they tell us that JM bisects KN, which means that KL is congruent to NL, and KN bisects JM, so that means JL is congruent to ML. Then they tell us that JK is congruent to NM. So then based on that, we have again that KL is congruent to NL, JL is congruent to ML, and then our given again, JK is congruent to in M. So this is congruent by side, side, side. All right, and then so Craig made a model using geometric shapes, including triangle shape as shown. For what value of x and y can you use a triangle congruence theorem to show triangles are congruent? And then which theorem did you use? All right, so looking at this, we would have 90, 60, so this angle has to be 30. Then we have 90, 30, so this angle would have to be our 60. So 7y plus 4 equals 60. So then solving here, we would subtract our 4. We get 7y equals 56, divide by 7, and y equals 8. And then for our x value, right, so then we would know that GH is happen to be congruent to 12. So then we'd have 8x minus 12 equals 12. Add the 12 over and we get x equals 24. Divide by 8 and we get x equals 3. Okay, so there's the values that work for that, for x and y, that would force this to be congruent. And then what triangle congruency theorem could you use? So we then have we know a side, and we have angle and an angle. So we could use angle, side, angle congruency. So going back to some previous ideas there. All right, and then number 9, little error analysis here. Let you guys read through that and then respond in kind. So then as we look at this, the error, so she is correct that it is 160, but the reasoning is not correct. It is not by side, 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 because we don't have 3 sides. I do have 190 is to 190. I have 210 is to 210. For side, 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 I would have to have that one to be 160, and that one would have to be 160, which it is, but we don't know that yet until we prove that these triangles are congruent. So we can't say that one's 160 quite yet, especially by side, side, side. If it was already side, 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 we wouldn't need to be asked this question. But what we do have is I have a side, I have an angle, and then I have another side. So we can state that those two triangles are congruent by side, angle, side, which since means corresponding parts of corresponding triangles are congruent. And so those is why we get 160.